Okay, thank you, Andrew, for that great intro. I'm going to show you guys today about parallel and perpendicular lines. I'm on chapter 5-6 with you guys in Algebra 1, and here we go. So, first thing is this is huge. Parallel lines have the same slope. Put a big star next to it. Put it in your notes. The same slope. Give me an example, which means if I wrote two equations here, if I wrote y equals 3x plus 2 and y equals 3x minus 1, they have the exact same slope. They both have a slope of 3, okay? If I was to graph these, I would have this one goes through -1 on the y-axis, up 3 over 1, up 3 over 1. So this is my slope. My line would look like that. If I was to graph the other one, y equals 3x plus 2, it's 2 here, and then up 3 over 1, up 3 over 1, down 3 over 1. So this would be the other one. And you can see, oh, I made a mistake here. That shouldn't be there. Up 3, I went only up 2. Okay, so, and you can see that that's what they look like. Parallel lines look kind of like train tracks. You know, they never intersect. That's another important thing. They never intersect. And they have the same slopes, okay? So that's parallel lines. And I also want you to write this down about perpendicular lines. Perpendicular lines, big star. Get some feedback from speakers or something. Okay. Perpendicular lines have negative slopes that are negative reciprocals. Okay, so let's talk about what that looks like. Negative reciprocal. So, for example, if I had example 1, y equals negative 2/3 x plus 1, I'm only looking at the slope. So the slope in this case would be negative 2/3. So when I say negative reciprocal, that means you change the sign of it and flip it upside down. So, the slope of a line perpendicular to it would be, if I put the 3 on the top and the 2 on the bottom and change it from negative to positive, this would be the slope. It would be 3 over 2, okay? The y-intercept doesn't matter, so it can be any y-intercept. So I got 3 over 2 x, and then you make up a number, I'll say minus 2, there it is. Plus 4, plus 7, my lucky number is 9, plus 9, okay, whatever it is. That's your y-intercept. Doesn't matter what the y-intercept is. Now, what do these look like? Let me quickly import a graph here. Oops, I need to go back. Okay, so back to my thing here. If I graph these, so I got y equals 2/3 x plus 1, y-intercept. Write the equation here. Y equals 2, negative 2/3 x plus 1. And then I got a slope going negative 2 over 3 is this direction, 2, 3. Okay, so I get something like this. More. Okay, so there's that line. The other line, I'm going to change colors to make the other one purple, is y equals 3x, 3 over 2x, minus 2 I said, so minus 2 is the y-intercept. And then I got a slope of up 3 over 2, up 3 over 2, up 3 over 2. Okay, so that's what perpendicular lines look like. They look like a cross, you know. If I rotated them, they're coming to 90-degree angles. Looks like the corner of a box in here, That's what perpendicular means. They're exactly 90 degrees and kind of like a cross. All right, that one's a cross on its side, kind of, but you get the idea. Okay, great. Let me write that down. Perpendicular lines form a 90-degree angle. Okay, question number 1. Write an equation of a line that passes through the point 3, 2. And is parallel to y equals 3x minus 2. And just to make it interesting, it says write your answer in y equals mx plus b. Okay, so first thing, slope of this line. You got to be able to figure out what the slope of the original line is, this one here. So hopefully you can all see that. M equals 3. Slope is 3. So what's the reciprocal? Negative reciprocal. This is the symbol, upside down T there for perpendicular. Parallel. Parallel is easier. So if this has a slope of 3, then anything parallel to it has a slope of 3. Now they want this point here, so I'm going to use the y minus y1 equals m times x minus x1 formula here, which is an equation for a slope of for equation of a line. I'm going to plug in the 3 in the front. I'm going to plug in the 2 and the 3 into the formula, so the y coordinate goes next to the y, which is the 2, and the x coordinate, which is the 3, goes next to the x. Now, this is easy just to get this into y equals mx plus b. I'm going to do distributive property. I get 3x. 3 times 3 is 9. And then get the y alone. I'm going to add 2 to both sides. And I get 11 over there. Y equals 3x. Oh, no, I don't get 11. I get minus 7. And that's the answer. Okay, number 2. Y equals 3x plus 2. Y equals 1/3 x minus 1. Y equals 3x minus 1. And y equals negative 1/3 x plus 5. And the question is, which two lines are parallel? Keep spelling parallel. Parallel only has one R. And which two lines are perpendicular? Let's do a U-try. Why don't you try this on your own? Hit pause. Okay, so hit pause and come back. Okay, so parallel, they have to have the same slopes, which means that one and that one both have a slope of 3, which means these are parallel. Y equals 3x plus 2 and y equals 3x minus 1. Perpendicular is a little trickier. So I see a 3. This one has a slope of 3. So if I flip that upside down, remember there's always a 3 over 1. So make it 1/3. And then I make it negative. So that means this has a slope of negative 1/3. So those two are perpendicular. Y equals 3x plus 2. And y equals negative 1/3 x plus 5. So those are perpendicular. What about the other two? The other ones, these two are both positive. So if I took 1/3, 3 here, and flip it upside down, I get 1/3, but it has to be negative. It can't be positive 1/3. So that one's not perpendicular to it. So those are my two answers, and that's it. Okay. Number 3. Write an equation of a line that's perpendicular to y equals 1/3 x minus 1. One-third x minus 1 that goes through the point. Two, 4. Perpendicular. Okay, so my slope here of that equation is 1/3. It's what's in front of the x. So if I'm talking about the slope of a line perpendicular to it, that means I have to flip the fraction upside down and change it from positive to negative or negative to positive. In this case, it's going to be starts out positive 1/3, so it's going to be negative, and then 3 over 1. So that's really negative 3. So that's my slope. All right, and they just want the equation. I'm going to take the easy way out because this form is beautiful for when they give you the point. You know, I can take that negative 3 and I'll plug it right in the front here. I know the slope goes here. And then I can take the x-coordinate and plug it in right there. Take that y-coordinate and plug it in next to the y. And I'm done. That's it. I don't have to go manipulating it. Clean up any double negatives. In this case, there are none. Y minus 4 equals negative 3 times x minus 2. If you want to do y equals mx plus b, you could. But you got to find out what the y-intercept is. You could take that point 2, 4, plug it back in. It's more work. I mean, you could do it that way. I showed you how to do that previously, but I would do the easier way. This will be my last problem, number 4. I want you to try this one. It's a you try. Number 4, it's very similar to what we just did. What is the equation of a line perpendicular to y equals 2/3 x minus 1 that goes through negative 2, 3. Okay, so it's you try. Hit pause and come back and I'll show you the answer. Okay, so perpendicular. So this has a slope of 2/3, which means if it's perpendicular to that, it will be 3 over 2 and negative. And I'm going to plug that into my equation. Y minus equals m times x minus. Slope is negative 3 over 2. The x-coordinate goes next to the x. And then I'm going to clean up any double negatives, which gives me y minus 3 equals negative 3 over 2 times x plus 2. And that is the answers. And that's it. That's all the time I have for today. All the problems I wanted to show you. See you all soon. Thank you very much.